Okay, so today we're going to be talking about kinematics. Okay, kinematics literally is how things move. Right? We've got mechanics, which is motion, and kinematics is the how things move. So we're not going to be describing why things move. We'll get into why later, but it's the how things move that kinematics is. So first things first, you need to know what your 5 variables are. Okay, get out your notes, go ahead and write these down. You need to know that d is displacement, v is velocity, v naught is your initial velocity, t is your time, and a is your acceleration. Distance or displacement is always going to be measured in meters. Velocity is measured in meters per second. Your initial velocity as well is in meters per second. Your time is measured in seconds. And your acceleration is measured in meters per second, or meters per second squared. If that doesn't make sense, you can think of it as like miles per hour per second. When you're driving down the road and you increase by 1 mile per hour every second. Then you're changing by 1 mile per hour per second. But in this case, in the standard physics units, you're changing by 1 meter per second per second. So every second that goes by, you're increasing by 1 meters per second, and then you're at 2 meters per second, and then 3, and then 4. You're always changing your meters per second, and it's a meters per second that you're changing. In math, we divide by the same thing twice. We can simplify that as seconds squared. So keep an eye and remember that your velocity variables and your acceleration variables are not the same, but they are similar. Now, when you see meters per second squared in your equation, that doesn't necessarily mean that you need to square that number or square root that number or anything. That's the unit that just explains what the number is. Okay, now those are your 5 variables that you will need. Okay, this is the part that typically tends to scare people. Okay, here are the 5 basic equations. Now, this first equation you've already seen and you've already used. We've written it as v equals d over t, or as tv equals d, but those are all the same as d equals vt, or tv equals d, or whatever. Okay, but that is an equation that you can only use when it's constant velocity. Okay, you don't get to use that equation all the time. In fact, as soon as you start accelerating, you have to use one of these 5 equations. Now, they may not make sense yet, but if you look at this equation, you'll notice that the one thing it doesn't have, it has 4 of the variables, 1, 2, 3, 4. T shows up twice, but it's still the same variable. But it doesn't have the v. So this is going to be really helpful when you're given a situation that doesn't have velocity. Then you'll use that equation. This has all the variables except d. So once again, this will be an equation that you use anytime you're dealing with acceleration, but you're not given the displacement, or you're not looking for the displacement. Same thing here. This time you don't have t. So once again, you'll use this equation anytime you're given a situation where you either don't know what t is, or you don't want to know what t is. And lastly, you have this equation for a. Okay? Remember your order of operations here. You want to add your 2 velocities together and then split them in half and then times by t. Or add the 2 velocities and then times by t, then split them in half. But the point is, remember to add these 2 together first if you know it. And if you don't know one of those, you'll have to do some algebra to figure it out. Okay? So, the thing is, there's that again. I don't know why that's on the PowerPoint twice, but that's okay. What you're going to want to do is always list your 5 variables. Step 1 is list your 5 variables. Okay? So, what are your 5 variables? Go ahead and pause this video right now and list out your 5 videos, or just 5 variables, and then or just whatever. But it's d, v naught, v, a, t. Doesn't matter the order, but those how they showed up in the Nope, that's not how they showed up in the PowerPoint, but that's okay. It doesn't matter what order they come in. Then you go through and you fill in everything that you can fill in. Okay, fill in what you know. So it says here you can get from 0 meters per second to 60 meters per second in 10 seconds. So what is that? What is that 0 meters per second? Well, that's how fast you're going at the beginning of the story. So that is going to be your initial velocity. To 60 meters per second. Well, that's how fast you're going at the end of the story. So that's going to be your final velocity. Let me put some units on there. In 10 seconds. That's time. That's how long it took you to do that. Okay. Now the question is asking, so this is where you get your unknown. The question is asking how far do you travel? What is that? Well, that is going to be displacement. That's your question mark. So notice we have 3 variables. We want to know what the 4th variable is, but we've never bothered to deal with time. So as I look over here at my equation, I'm going to use the don't need a equation. So that equation is d equals 1/2 v naught plus v times t. Now that I have that equation written down, I'm going to plug in my numbers. Okay, so I know my d is still my question mark. So I'm going to leave it as a d. Okay, 1/2, v naught is 0, v is 60, t is 10. Now let's put that all together. So 1/2, 0 plus 60 times 10. So 1/2 times 60 times 10. So it's 1/2 of 600, or it's 30 times 10. But either way, you're going to get d of 300 meters. Okay? And that's it. That's your answer. If this were a quiz, I would grade you on, first of all, did you list your knowns and unknowns? That's bad. Did you list your knowns and unknowns? Okay. Did you write down your equation without plugging numbers in? Did you show your work? Did you get to the right answer? Remember, units are important. And, like always, I'd give you a point for something else random. Okay, let's do another example. While cruising along a dark stretch of highway with cruise control set at 25 meters per second, you see at the fringes of your headlights that a bridge has been washed out. You apply the brakes and come to a stop in 4 seconds. Assume the clock starts the instant you hit the brakes. Using kinematics to determine how, I should just say use kinematics. I don't know, this is bad grammar, but that's okay. This is an English class. Use kinematics to determine how far the car traveled during braking. Okay? I guess I could have just crossed off using kinematics. Using a kinematics? Oh my gosh, this is so bad. Okay? Using kinematics. Whatever. Okay, so what are we going to do? We are going to figure this out. So, first part of the story is, or what's our first step, I should say, is listing our knowns and our unknowns. So, D, V, V, A, T, I don't know, whatever order that comes in. So the first thing is cruise control is set at 25 meters per second. So that means my speed at the beginning of the story is 25. Okay? Bridge has been washed out, so you apply the brakes and come to a stop in 4 seconds. So we know my time is 4 seconds. Okay, how far the car traveled, question mark goes there. Now we have a problem, and that problem is they don't mention our final velocity. So we just give up and just, life, it doesn't matter anymore. Physics is wrong. No. Okay, we have to read between the lines a little bit. How fast are you going at the end of the story? Well, it mentions here you slam on your brakes and come to a stop in 4 seconds. So that lets us know the velocity at the end of the story is 0 meters per second. It may not be explicit, but it's there. Okay? So again, now we need to pick out which equation are we going to use. And so if we look over here at our kinematic equations, we see that we're going to use the don't need a equation again. Okay? So that is d equals 1/2 v plus v times t. Okay? So our displacement, still our question mark, our 1/2 times 25 plus 0, or no, 0, it doesn't really matter the order you add them together, but 0 plus 25 times 4. So 25 times 4, 25 plus 0 is 25. 25 times 4 is 100, split in half is 50. So our displacement equals 50 meters. Okay, and there's a part 2 to this question. Your car can accelerate at 5 meters per second. Never mind, this is not part 2. This is a completely different problem. But whatever. If your car can accelerate at 5 meters per second, start from rest, how far will you travel during the first 8 seconds? Okay? So, d, v, v, a, t. I know my acceleration is 5. I know I'm starting from rest, so that's a hidden variable. My v0 is 0. Okay, I want to know what happens in the first 8 seconds. That should be an S. And how far, so that's my question mark there. So I'm going to use my don't need V. Okay, now don't need V seems like kind of a scary equation. Okay, it's this one up here. It's probably the scariest of the bunch, but that's okay. D equals V naught T plus 1/2 AT squared. So let's plug in what we can. Okay, so our D is still our question mark. Okay, our V naught is 0. Our T is 8. 1/2 times A, which is 5, times T, which is 8 squared. Okay, 0 times 8 is 0. 1/2 times 5, 8 squared is 64. So we'll need a calculator for this one. Okay, so 0.5, oops, that's negative. 0.5 times 5 times 64. So our displacement in this case is 160 meters. Okay. So, good. That's kinematics. Basically, you list your 5 variables. Okay. You fill in 3 of them. You put a question mark next to a 4th. Whichever one you haven't chosen is the one you get to cross off. Then you come over here to your kinematic equations. You find the one that you crossed off. And you come back here and you write it down. And then when you've written it down, then you go through, fill in the numbers, and do the math. And that's it. So good luck.